Much like you have a test that you can perform algebraically to determine whether a function is symmetric with respect to the x, y, or origin, there's also an algebraic test you can perform to determine whether a function is even or odd. So this test says that a function is even if you plug in negative x in place of x and you wind up with the same equation you started with, then it is an even function. Now, if you plug in negative x and you wind up with the very opposite of the equation that you started with, then it is an odd function. So this one is a little different from plugging in the algebraic test for symmetry. This one, you only need to plug in a negative x each time. So when you plug in negative x, if you wind up with the same thing you started with, then it's an even function. But if you plug in negative x and you wind up with the very opposite of the function you have, then it's odd. Now, if it doesn't fit either of those categories, then it would fit in the category of neither. Let's do an example and it'll make more sense. So we want to test to see if it's even, so we're going to remove all the x's and replace them with negative x. Recall that when you have an even number of negatives, that is going to equal a positive. So this first term is going to be positive. Now this positive along with this negative being multiplied, so a positive multiplied with a negative, it's going to make this term a negative. So I'm going to go ahead and simplify. And as we can see, we have the same exact thing that we started with, same exact equation, so we can conclude that this is an even function.